All right, master students, let us proceed from where we left. Uh, Sometimes there are some problems with the technology. Sometimes you record and then the video tells you, oh, it's reached an end. So you have to really come back from where you left. But I hope you can be able to really understand, to really follow up on what you were talking about. All right, I'm just trying to to get to see where I was. Um, so let's look at this structure here. Um, uh, what can you say? I said the black balls are carbon, and then say the white ones are hydrogen. So these are the bonds, yeah, and then these are two different groups here. Now there is something which I'm going to show here. Maybe maybe I can have atom A, then I have B, then I have C, and then I've got a circle at the back, and then I've got probably D, E, and then F. I'm just trying to avoid putting groups. Okay. Let me say there is A, B, C, D, E, and F. So this is something which you call the Newman notation, in which the carbon next to you, nearest to you, is being shown as a dot. Is being shown as a dot. So this one is going to be closest to you. It should be shown as a dot. The one farthest from you, it will be shown as a circle. Yeah. And then so this one which is shown as a dot is the one which is nearest to you. Now I can say it has atom A, B, and C, and then the one farthest from you has got maybe what D, E, and F. Now there's a way in which you can illustrate here. In this case, uh, these two groups are going to be nearest to you, and therefore they can actually clash. Yeah, they're going to be very close to you. So this is going to be said to be seen in which the bulky groups are going to be next to one another. So it's going to be highest in energy. And then there is the opposite case in which the bulky groups are going to be away from you. This is called the anti-conformation, which is the most stable. In between, then you can have this conformation here in which the bond angle is 60 degrees, and also this other one as well. It's also 60 degrees here, and also this other one is also 60 degrees, and also this other one is also 60 degrees. Yeah. So there are a number of broach conformations, and then there is only one or maybe two scene conformation in which the bulky groups are going to be facing one another, and then in this case that's the scene SYN, yeah, and then the anti is when the bulky groups are going to be away from you. Are you okay on that? They are going to be away from you. So this is something which you may have dealt with at undergraduate, but in this case, using a video and probably with the molecular models, you can actually see this how each of those conformations are leading uh, to the different energies uh, of the structure. I mean, of the what do you call it? The structure of the molecule which you are dealing with. All right. So that's the first aspect we'll be talking about, the conformation of, in this case, I'll be talking about saturated alkanes. Now, um, what you're going to be dealing with is that is that you can also have a double bond. Let me just try to see. Let me just try to see. Uh, excuse me. Maybe I've got that, and then let me remove. Let me remove that. Okay, let me just try to show here. Okay, and let me excuse me. Okay, good. Okay, let me just try to show. Uh, I've just tried to remove a double bond, which was not what I intended. Uh-huh. Excuse me. Okay, there is a group there. Excuse me. And then I've got another group here. And then probably I've got another group here. Good. Okay, good. Now, what can you see here? A double bond, I'm just showing with this one as this, they're a bit twisted, but in this case, the double bond is going to be flat, yeah? I mean, this said to be like a double bond. But if I may use something like this white paper as a plane, you're going to see, as opposed to the alkanes which were tetrahedral, these ones, all the atoms, if I'm dealing with a double bond, are going to be lying uh, on a plane. Like in this case, there is the white one for the hydrogens, and then probably another atom, but they are all lying on a plane, and then the bond angles are all 120 degrees. They're all 120 degrees. So I think you'll be able to see that uh, 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 maybe I may not be able uh, to show, but if you're going to have like for a triple bond, let me just try to see whether I can illustrate that. If I'm going to probably put a triple bond, okay, then suddenly the remaining atoms on the hydrogen becomes flat. So this is linear. This is said to be like a triple bond. The bond angles are 180 degrees. Okay. So if you're going to be showing even a complicated natural product, yeah, um, uh, the good thing about this course is that it's going to lead you to know how to correctly show the structures when you'll be doing research in your second year. That you'll be able to probably know I'm dealing with this. If you'll be dealing with extraction of natural products and the rest, so you'll be able to really show the proper geometry. So in this case, if you're going to be having a triple bond in the structure, you need to know that the bond angle, all the bond angles are 180 degrees, and that is sp hybridized carbon. Now, something else which I will also uh, uh, which you also need to know, which is going to be leading us to the next part of the conformation analysis, and that is the rules for ring closure. You're going to see that uh, that that uh, uh, alkanes like the ones which I was showing you about, if they are going to be, if they're not going to be in a ring, then they're not going to be, then there will not be, the only thing which we'll be talking about will be steric interaction. But if you're not going to be forming a ring, then you're going to be introducing something called a ring strain. And the ring which has the lowest strain is the six-membered ring. Then five-membered ring and seven-membered ring have got the next lowest ring strain. Yeah, three-membered ring and especially the four-membered ring are going to have the highest ring strain. In this case, I've illustrated a four-membered ring in which the bond angles are 90 degrees, and in this case, it also contains a double bond and the rest. And once again, I'm really hoping out of this one, we'll be able to have a case whereby rather than it being an online course, maybe at one time or another, or maybe as you'll be studying for a CAT or an exam, you'll be able to really come to my office and say, hey, you want to use the the molecular model to be able to visualize this. That is allowed, yeah? So that you can say, can I borrow the set for the molecular model so that you'll be able to see for yourself these things which I'm illustrating. Maybe if you are going to be making a 5-member drink and say, hey, in this case, as it cyclises, there is less ring strain. If I'm going to make a 6-member drink, hey, maybe in this case, there is no strain at all. Yeah. So I think that's what I'll be looking at in the next uh, video as to the the uh, the ring systems that contain the 6-member ring. Yeah. So that in this case we'll be talking about something like the chair and the board to be able to see uh, that it actually doesn't have uh, uh, ring strain, and you'll be able to see exactly. If we'll be talking about something like the chair and the boat, I'll be able to really show you how it is. But I think let me stop there. I think I've really talked for probably 30 or 40 minutes. I'm going to pause there, and then the next video will now be showing about the conformations dealing with the 6-member drill, and then from there I'll talk about a few things uh, as we lead towards the next topic, still within the conformation analysis, dealing with the rules for the ring closure. They were they were formulated by another gentleman called Baldwin around 1977. There, I think I'm also. I'll try to see whether I've got the original paper by Baldwin uh, to be able to show you those rules that uh, if you'll be talking about forming a 3-member drink, 4-member drink, 5-member drink, 6-member drink, and probably 7-member drink, you'll be able to see, uh, depending on how the nucleophile and the electrophile are going to be oriented, you're going to say, hey, this formation of the ring system is going to be disallowed, or it's going to be favored or disfavored. Yeah, yeah, you're going to see that there are those rules that are going to lead to the formation of those rings. So I think for now, I think let me stop there, and I think we'll be able to proceed from there after this. Thank you very much. Okay, good.